Find the derivative of f of t equals the cotangent of 5t divided by the square root of t squared plus 9. So f of t here is the quotient of two functions. We have the cotangent of 5t and then divided by the square root of t squared plus 9. So we're going to make use of the quotient rule, but before we do that, let's rewrite that denominator to a fractional exponent. It's t squared plus 9, and then to the 1/2 power. So the derivative will follow a quotient rule. Quotient rule says take the derivative of the numerator. Well, the derivative of cotangent is negative cosecant squared. Leave the inside alone, but then multiply by the derivative of the inside to complete the chain rule. Times the denominator left alone, and then minus the numerator left alone, times the derivative of the denominator, which is a power rule. We'll bring down the 1/2. Leave the inside alone. Subtract 1 from the power. I will call it 2/2, and then multiply by the derivative of the inside, which is a 2t. All of that divided by the denominator squared. So that's t squared plus 9 to the 1/2, and the entire thing squared. So f prime of t is equal to, I'm going to bring the constants to the front. So I have in this first term a 5. I'll put it out there with that negative. So I have a negative 5. I'll next write the t squared plus 9 to the 1/2, and I have the cosecant squared of 5t. This second term, I'll bring the constants. I have a 1/2 and a 2. Those multiply each other. That'll be 2/2 or a 1. And I'll move those out there with this negative. So I will have a negative 1. I also have a t that I'll move to the front. So I have a t. I have a t squared plus 9 to the 1 minus 2, negative 1/2. And then I have the cotangent of 5t. And all of this is divided by t squared plus 9 to the 1/2 to the 2. Multiply the exponents. 1/2 times 2 is 2/2. 2/2, of course, is 1, and we'll be able to write it as just t squared plus 9 in the denominator there. Now, we do have a negative exponent in the numerator of the second term, so we can put it in its denominator. That's the only negative exponent. So one option is to factor the numerator. Another option is to get the common denominator. Both of them work. So I'll just rewrite the first term exactly as we see it. But the second term here, I have a t and I have a cotangent of 5t. And I have a t squared plus 9 that's being moved to the denominator so that it can now be to the positive 1/2 power. And that's only in that term. Now, in the overall denominator, we have t squared plus 9 to the 2/2, which means to the 1, which means we don't have to write it to a power. And we can just call it t squared plus 9 for now. Our next step, we need to combine these numerator terms together, this and this. Well, we need a common denominator in order to do that. So f prime of t will now equal to, I have a negative 5, I have a t squared plus 9 to the 1/2, I have a cosecant squared of 5t, and I'm going to multiply this by what will be the common denominator, t squared plus 9 to the 1/2 over itself, to produce the common denominator. And then we have minus t cotangent of 5t. I'm not going to do anything with that term, over t squared plus 9 to the 1/2, and then the entire thing divided by t squared plus 9. Okay, now we're going to combine those fractions together. They're over the common denominator. Now this first numerator, everything is multiplied. All this is multiplied. And specifically, I'm going to put that term and that term together because I can add their exponents. 1/2 plus 1/2 is 1. And so really, I just have a negative 5 t squared plus 9 to the first power times the cosecant squared. Cosecant squared of 5t. And then I have a minus t cotangent of 5t. And all of this is over that common denominator of t squared plus 9 to the 1/2. We've combined them over a common denominator. And then the entire thing is over a t squared plus 9. Well, that t squared plus 9 can be made into a fraction by putting it over a 1 so that we can reciprocate and multiply it. And we're going to want to do that so that we don't have a fraction over a fraction. We want a single fraction. So f prime of t is going to equal Alright, so we have the negative 5 times t squared plus 9 times cosecant squared of 5t. We have minus t cotangent of 5t. I'm not doing anything with that numerator. We have it over that common denominator of t squared plus 9 to the 1/2. Reciprocate the denominator, so that'll be a 1 over t squared plus 9 to the 1. Now I'm going to multiply these. In the numerator, we just multiply the numerators, and 1 times anything is that same thing. So the entire numerator will be as is. So minus 5 t squared plus 9 cosecant squared of 5t, and then minus t cotangent of 5t over, and then the denominators, we multiplied those, but since they have matching base, they're both t squared plus 9s, we add their exponents. Well, the exponent of this one here is right now a 1, but instead of writing it as a 1, let's write it as a 2/2 so that we can add them. Because we have a 1/2 plus a 2/2, we're getting a common denominator of their exponents. And this will become then t squared plus 9 to the 3/2 power. We have the 1/2 plus the 2/2 to give us 3/2. And there's our derivative f prime of t.